History rewards the innovator, the pioneer, the trailblazer. For over 30 years, Supermicro has been fueling innovators and visionaries with the industry's best computing resources. We have built the industry's widest portfolio of storage servers with the largest open ecosystem of leading storage hardware so that you can be first. Welcome to Supermicro's 2025 Open Storage Summit.
Hello, and welcome to the Supermicro Open Storage Summit, where we will dive into storage as a service from a cloud service provider perspective, also known as CSPs. In this session, we'll dive deep into how storage as a service is rapidly transforming how enterprises consume and manage their data infrastructure, shifting from traditional capital-intensive storage models to flexible, consumption-based services delivered by cloud service providers or CSPs. This episode dives deep into evolving landscape of storage as a service from the perspective of CSPs, exploring how these providers are redefining storage delivery to meet the demands of modern workloads distributed across on-premise, edge, and public cloud environments. We examine the key drivers behind this shift, including cost, efficiency, scalability, security, standardization, and simplified management, and how CSPs leverage advanced technologies like AI-powered capacity optimization and performance-guaranteed SLAs to deliver seamless cloud experiences anywhere data resides. By unpacking the business model, operational frameworks, and innovation strategies that CSPs employ in storage as a service offerings, this discussion reveals why storage as a service is becoming a foundational pillar of digital transformation initiatives in hybrid cloud architectures. As we explore storage as a service through the lens of the cloud service provider, it provides and reveals a dynamic shift towards flexible, secure, and intelligent storage consumption models that empower enterprises to navigate digital transformation with greater efficiency, confidence, and increasingly data-driven world. To help me break this down, I'm really excited to have this panel with me because I think when you look at how this landscape is really delivering, especially with all of the stuff around AI coming on board, it's so important to get these different views. So first, I'd like to welcome Cliff Madru, who's over at Iron Mountain, one of the customers. This is really great to have you on board. So thank you for coming on board. Then we have Giorgio Regini, who's with Scality. Thanks for coming on board. Rex Manso, who's with Lightbits Labs. And Mark Iskra from Intel. Mark Tangway from WD and Western Digital. And not least but not last, Paul McLeod with Supermicro. Thanks for everybody for coming on board. I think, given that we do have a customer in this session, it would really be great if you could kind of take us through as you've built out storage as a service over at Iron Mountain.
Well, first off, Rob, thank you very much and appreciate the opportunity from Supermicro to be here and from the rest of the panel to have the opportunity with such experts. But listen, it's been quite a journey with Iron Mountain, both professionally and personally for me. I've got 15 years with the company. We've been through a big evolution, but over the past 70 years, we've obviously continuously evolved our business. Many people know us today for our inventory management and logistics, but we wanted the opportunity to share much more, what we're doing broadly across the digital spectrum and otherwise within our infrastructure services, our data center businesses, and then, of course, our Iron Cloud and our digital storage services. Again, many people know us for the trucks that they might see driving around or the shred bins that they might find in different facilities, but we've expanded our portfolio of services well into the data center space, well into the digital space, and into the IT asset and lifecycle management space as well. It's a unique blend of solutions, and it really lends us into a unique opportunity for our customers as we look at a transformation between physical and digital and how we bridge that gap for many customers. So not only have we had our own internal transformation of our services offerings, but now we've expanded our portfolio into services that help our customers really with their transformation efforts and their ability to leverage both physical assets and how they become both digitized and then leveraging, of course, their electronic assets as well. When we look at the services that we offer, all the way from physical records management, through to digital storage, and then how we can unlock data with AI and ML and leveraging some content management resources and platforms that we offer to our customers. On the slide that we're showing, I wanted to talk just a little bit about that real center point around harnessing the power of the data and really what that can mean. Storage plays a big part of being able to make sure that your data is accessible, that it's stored on the right tier, that you're governing the information in a way that is, of course, leveraging best practices around how we protect that information. That's a big part of what we'll get into as we talk about our storage platform and some of our partners and how we're leveraging the solutions that we have to ensure the appropriate protection for information. But then being able to unlock the power of some of that data, both bringing it to the right tier of storage and then, of course, being able to leverage the right tools within generative AI, some of the ML models that we've built to unlock value from whether it's digital documents or rich media files or whatever it might be that we help customers with, both digitizing that content that may be in physical form today in the form of documents, open reel type tapes, old recordings, things of that nature. We have a media and entertainment business as well. And then, of course, we have an archiving business, so we've done a lot in that realm. But today we'll focus heavily on kind of the storage elements and what we've done to build out our storage as a service platform, the IronCloud. We take our customers typically on a 5-step journey for digital transformation. First and foremost is just getting a handle on what assets you have, whether those are physical or digital in nature, understanding what it is you need to keep, reducing risk of keeping things that you shouldn't be keeping, for an extended period of time, going through what we call like rot analysis, where we're looking for redundant, obsolete, or trivial type information, whether that's in digital form or physical form. And then being able to take that and digitize the content that you want in digital form. And of course, being able to store that effectively with protection in mind, thinking about cyber protection, which I'll talk a little bit more about as we move further along here, and ensuring that you're leveraging the right types of storage for the type of data that you're going to be accessing. Then automating, being able to leverage tools to automate both from a process point of view, workflow point of view, and then getting into the data extraction and the value-added elements where we can truly unlock the value, whether that be monetizing assets, gaining more information from the data that you have that becomes valuable to your end customers potentially. So there's a lot we do across the spectrum, whether it's from financial services to healthcare or otherwise. And at every stage of the journey, being able to govern that information effectively with a security in mind becomes a critical component as well, and we'll talk about that. We've built IronCloud around cyber resiliency, being a protected data storage platform. We've wrapped in services as it relates to being able to move from legacy systems. Longevity becomes a critical thing. How do you access data? What do you do with historical data that you need to keep? So having the right types of services so you can retire applications, that all becomes typically a part of the types of solutions that we're offering for customers. So between our IronCloud kind of data services, making sure customers are ready, for protection against cyber events, ransomware type events, and otherwise, and ensuring kind of that long-term preservation and access that's required. And in order to do that effectively, having the right types of storage tiers becomes real important as well, both from a longevity point of view, long-term retention, also from a protection point of view, being able to offer things like air gap storage, putting data down. We're proud to still offer the ability to bring it down into tape as well, and then offsite that tape to have that true kind of air gap and protection on information. And it is something that makes our cloud quite unique and one of the key areas that we focus on from a storage and cyber resiliency point of view. So the way in which we approach this with customers typically is to look at an overall total cost of ownership, a TCO, thinking about the types of data that they're trying to manage, that they're having to protect, thinking about the best way to do that. Obviously, they have cloud workloads. They typically have on-premise workloads as well. And we're balancing kind of the right protection approach, right, for those different types of workloads. That becomes an important part of how we think about scalability and design of the architecture as well of the storage platform, mainly from a connectivity point of view, different cloud workloads coming in, as well as having dedicated circuits when required and things of that nature. So all of that becomes a big part of as we're building out solutions for our customers and ensuring that we put the appropriate protection in place for them. The goal here is having, from a cyber point of view, data immutability, being able to offer the air gap, having that kind of multi-layered protection, and then, of course, the resiliency and ability to restore and recover that data. In terms of the foundation that we've built with many of the providers that I'm sharing the panel here with today, a big consideration is around scalability, having a scalable foundation, having the appropriate standards in place so that we can scale both within a region and globally as well, building out the appropriate kind of like kits that we're going to deploy, and working with some of the teams here today, Supermicro and Scality, Intel and WD, all coming together, kind of building out the appropriate systems that give us that scalability that we're looking for and that unified deployment capability. And then, as I've mentioned multiple times, we are built for security and protection, and that's been a key pillar of our design, and is built into all the hardware and software choices that we've made along the way.
That's great. I think that gives people a good overview of where things have come from and how you've really looked to design things out. And I think from that perspective, again, I love having this panel because it's all the things that you're using and how the rubber meets the road with that. So let's start with the first piece of road. Giorgio, why don't you kind of give us an idea from a Scality perspective how you're helping cloud service providers like Iron Cloud with that in Iron Mountain?
Thank you, Rob. So Scality is a software-defined object storage company. We go after a large deployment, petabytes to exabytes, customers all over the world. Top use case would be cloud infrastructure, what we're going to talk about today, AI, and the immutable backups. And they go all hand together, and especially our own cloud, it's cloud for backups. So where do we fit? So people maybe don't know this, but Scality is a spin-off of a company that was going after service providers only. So we know kind of that DNA. So it's all about security, scale. So some of our customers have themselves hundreds of millions of customers. So that means the storage needs to know who is who and scale to that kind of levels. One of our customers has 100 billion buckets. Why? But because they can. But it's things that you need to scale for. You also need to give them one single view of everything that's happening. So even though somebody might be doing something in that data center somewhere, you need to surface it quickly, and you need to know attacks, bad traffic, all these kind of things in a central fashion. It's all about economics too. You want to resell the service, you want to be competitive, so we cannot waste data. So erasure coding, as few copies as possible with highest durability. In terms of use case, so it's very interesting. So backup is one, we talked about it. Also video streaming, YouTube competitors, video surveillance, they use object as a cloud service to store this. Long-term archive, think of it as a cold storage that you want to use for long-term. And it doesn't matter what people do in the end. They're going to use the same platform for many different use cases. And that's how you do economic of scales. You want to deploy one big pool of storage, which is Scality Ring, and then as many apps as you need go on top. So one of our customers is a bank. They have 2,000 applications because they tell their developers, use this service for whatever you need. And they just went at it. And so we have no idea of the traffic that's coming. So that creates some challenges for us. And it's all about metadata, scaling, and being able to handle unpredictable traffic. So that's where we fit. In terms of the Iron Mountain, I love this deployment. So you're looking at 0.5 exabyte of storage, over 2 data centers, West Coast, East Coast. There's copies between both data centers all the time, both ways. If you look at the architecture, there's mainly 2 tiers, I would say 3 tiers. One is the connector where the traffic comes in. This layer needs to have utmost security because it's connected to the internet, right? So it's all about multi-factor authentication, multi-tenancy. And this, you want to scale it as much as you need without touching the storage piece. So you want to scale them independently. Then you have a storage, 120 servers, nice fat Supermicro servers. And these ones, they are protected in the back, and they scale as well in their own way. So if you need more capacity, you scale that layer. You need more performance, you scale the connector layer independently. Then you have tape in the case of Iron Mountain. And we have something called a data management, extended data management, that takes care of all the life cycle. So transition data, expired data, compliance too. So things like object locking, compliance, immutability is managed at that layer. And I think that gives you a good overview of the architecture.
That's great. I think, again, this is why I think it helps people understand how they can look at architectures. And to the earlier point, I mean, again, it's about how do you, from a cloud service provider, how do you make money as well? So, bouncing off of that, Rex, why don't you give us Lightbits Labs' kind of view of what's going on in the CSP market here?
Appreciate that. So thanks for approaching that from an object storage. It's going to be from a block storage perspective. And at Lightbits Labs, we invented the NVMe over TCP protocol, which we think fundamentally democratizes access to very, very high-speed, low-latency block storage, typically used for database and analytics workloads. So CSPs, you're different. You adopt things a lot faster. You have to. You can draw a straight line between the underlying infrastructure and your end user customer's experience, and a straight line between that performance and your revenue stream. So competing with hyperscalers is really tough. You can't build typically at that scale with as many choices. And so enabling you to do that, to establish a discrete high-performance block storage tier can unlock new revenue streams and can improve customer experience and can enable you to take on a broader range of workloads. So we know you're dealing with margin pressure, predictable, low latency and high performance at scale. And so we can say with 100% confidence that you will not find this holy trinity we're representing here on the slide of cost efficiency, resiliency, and high performance in any other platform. We aim for being twice the performance and half the cost of traditional SAN storage. That's so 90s. And giving people choice to do something a little bit differently. So a disaggregated, software-defined block storage tier deployed over commonly available Ethernet that's multi-tenant, resilient, and then has all of the data management and data protection features one would expect from enterprise block storage. Your customers are probably somewhere along this journey, in this continuum we're talking about right here. Things didn't change for the better part of a couple of decades, and the hypervisor and orchestration plus the underlying storage foundation were what we'll call the usual suspects. That's changing rapidly. We think there's more change that's happened here in the past 2 years than the prior 20. And this is causing many of you and your customers to kind of rethink the underlying storage foundation and to go with software-defined, more flexible, with an entirely different cost profile. So Lightbits Labs' commitment here is to meet you and to meet your customer where you are in this journey. We do have easy plug-in integration with this entire array of hypervisor and orchestration platforms that is intended to make adoption fast and easy. In terms of what this all looks like and how it comes together, there's always the tendency when you claim a strong performance advantage and a low latency advantage to stitch in proprietary parts. We have, I guess, avoided that temptation. We work on commonly available, properly spec'd servers over high-performance Ethernet, connecting to a cluster of Lightbits storage that's anywhere from 4 to 16 nodes. So there's no modification that happens on the host. From a single cluster, one can get up to 18 million IOPS and 5 petabytes of capacity. Multi-tenant, quality of service are an absolute must for this category. In terms of what this architecture looks like and how it all comes together, you, the service provider, will take your application compute servers. You will simply connect them to a Lightbits cluster via high-speed Ethernet, and away you go. We have others who have started in our space and really made themselves kind of a niche solution by using proprietary components. We've really avoided that temptation. We want our solution to be easy to adopt and broadly available on commodity parts and commonly used networking. So that's kind of our philosophy in terms of how we've expanded and solved problems for folks. No modification or customization on the client layer is required. And basically being able to, with commonly available, properly spec'd servers to create a high-speed storage cluster that delivers tens of millions of IOPS and many, many petabytes of capacity that's able to be carved up in a secure multi-tenant fashion with quality of service is really what we aim for. I think the last point we'd like to make is transparently integrating with whatever hypervisor and orchestration layer our service provider customer has created is really important, and giving them the ability, along with partners like Supermicro, to either start small to launch a net new service, or to create a premium tier that generates incremental revenue, or to start at large scale. We're okay with that too, and we'll kind of meet you where you are on that piece.
Yeah, I think that to me is really critical, and we'll definitely get some more as we go into the stack here, but really understanding that all of these pieces coming together are key. And to your point, even seeing OpenStack in there, which is now part of CNCF as the Open Infra group moves in there, comes closer to cloud native types of things, where that had been one of the standards there. There's so many different places that the CSPs have to integrate in. So completely agree, and I think all of that comes together. Funny enough, we have Intel can actually, Mark, why don't you take us into where Intel plays from a CSP perspective as well?
Sure, thanks, Rob. So as a cloud solution architect at Intel, I have the good fortune to work with a wide range of different cloud service providers. And just to kind of lead that off, and also echoing what I think a lot of my other colleagues here have already said, there are a bunch of requirements that almost all CSPs have in terms of standing up storage as a service, whether it's publicly available or just internally consumed. The first obvious one is that there's just a very wide range of performance requirements, all the way up from extremely high I/O rates to feed the beast when you're doing AI training, down to like glacial storage and everything in between for compliance purposes, for billing purposes, for inferencing purposes. So there's a huge range of stuff that has to be addressed, and it takes different kind of components for all these things, and the physical requirements change quite a bit depending where you are on that scale. The other thing I've noticed is, in general, particularly as CSPs become bigger, they tend to want to stand up their own stuff more and more. And typically, cloud service providers, unlike enterprise, maybe are more entrepreneurial. They are startups typically from the beginning, and then they grow, but they have deep technical strength, and so they often like to roll their own stuff. And they also have a need to differentiate on different technical offerings. So they build in new features, they do innovative things. I mean, that's what really creates their business, and that's what makes them different and unique. And they also have telemetry needs. So they're wanting to collect different kinds of data, and by doing things themselves and using kind of a white box approach, they're much more able to get to the thing that makes them who they are. The other couple of requirements that you often see, they're very cost sensitive. No surprise there, everybody is. But what you do see is as things scale up, they try to wring out more and more of the cost. So the scaling side also brings a need to do everything very efficiently. And this is where taking off-the-shelf components, this is what I love about Supermicro too. They have just a wide range of white box type solutions for storage. You can get very high density solutions, a wide range of powers and components and everything else. But these kind of building blocks are the essential DNA that allow you to build up the storage as a service. And then there's all this power constraint thing that also goes on. It's extremely hard for service providers to increase the amount of power going into a rack, even when they want to do a tech refresh. And so you really have to engineer for the power that's available, and that brings in a whole new set of constraints in terms of the processors, the devices, the systems, and even the networks that you're going to deploy. So they're constrained by all these things. Reliability, durability, the ability to keep things going for an eternity in some cases is just part and parcel of the business, particularly for compliance reasons. And then security. Security is very crucial also. And you're seeing more and more people concerned about making sure that even data in use is encrypted and protected. So data in rest, data in flight, and even data in use all need to be protected. And this is a growing concern for many, many different consumers of online cloud services. So with that, let me talk just briefly about Intel. And there are like at least 3 ways that Intel really helps to address some of these requirements. So first of all, we make great silicon. We're been in the silicon, we kind of invented the integrated circuit and all this stuff that goes into our servers today. And I'll touch on some of those features, but beyond just creating silicon and chips as we know them, Intel is also very active in working with other partners. So, we love Lightbits, we love Scality, and so many other companies. We work with them to help them also get the most out of our stuff. There's a natural synergy there where we can build and do things together. So we invest in that. The other requirement that we come into or way that we contribute is through open source. So you can influence a world of people that are taking these kind of things and putting them together by open sourcing stuff. There's no monopoly on good ideas, so you put an open source project out there and then everybody can build on it, and corporately everybody benefits. But Intel sees the opportunity there, and we've done quite a few different open source projects to help enable storage as a service in the CSP space. So coming back to silicon, Intel has, for instance, some of the, with Xeon 6, codenamed Granite Rapids, our latest processor built on the 3 nanometer technology, we have the industry-leading number of PCIe Gen 5 lanes. We can offer up to 136 lanes in a single system. So what that means is you can just attach an insane number of not only NVMe drives, but you can also have NICs and other components, all that stuff just laced together at a very high performance level. So that's industry-leading technology. We also are offering MRDIMMs, which offer much higher throughput, like 30% higher than most of the current RDIMMs that are being used. So with MRDIMMs, we're currently supporting up to 8,800 million transfers per second, whereas RDIMMs are typically running up around 6,400, which is still extremely fast. So that's another area where our silicon really is differentiated and offers, particularly for the AI crowd, the ability to get extremely high I/O rates going on. Another thing that we've pioneered and we believe very strongly is the use of accelerators. Particularly for crypto accelerators, this is kind of where Intel started with accelerators. You need these in storage. If you're doing eraser coding, if you're doing compression, if you need secure socket connections, all of these things are very computationally intensive. And by using the right tool for the function, for the problem you're trying to solve, you can get much better efficiency. So our accelerators, including QAT, AVX, IAA, all of these accelerators are built into every chip that we make. Well, every Xeon chip, at least every Xeon 6 chip. And we've been doing this for 3 or 4 generations. So these accelerators are available to help you get optimal storage performance without having to put in as many cycles, without having to put in as much power. And we also open source a lot of the APIs that use this. So we upstream to Linux, we upstream to OpenSSL, to many other places where you can actually get these accelerators working for you without having to change your code or even being aware of it. So as much as possible, we try to make these accelerators transparent. And this is our hedge against Moore's Law, basically. We use the made-for-purpose accelerator that does the job you need to do for storage. We also put a heavy focus, particularly in the open space world, on DevOps support. So we've contributed heavily to the Kubernetes community. We have node discovery tools that allow Kubernetes to know what resources are available, and you can schedule these things. Also, very recently, we introduced something very germane to the storage world, which is I/O resource isolation for Kubernetes. So this allows you to solve essentially the noisy neighbor problem. So imagine if you have 100 or even 1,000 containers all running on one server. Everybody's trying to get I/O going through the same physical device, and it only takes one bad actor to consume almost all the bandwidth, and then everyone else suffers. So we've come up with a solution to that problem, and we've open sourced it. Runs for anybody using Linux, and so we're constantly trying to help drive and feed and support that ecosystem that's doing storage. So that's Intel in a nutshell.
I think it's great to really dive into that, and where Intel kind of opens up all the lanes to the disks and kind of delve into the disk world with Mark from Western Digital, WD. So why don't you help us understand what you're doing in the CSP world as well?
Yeah, thanks, Rob. And at Western Digital, we have our UltraShard Data Center series of hard drives, which really is the core foundational storage drive that's utilized by CSPs like IronCloud and many others. And today what we're going to talk about is really the alignment of the storage media technology, whether it's SSD for hot, HDD for warm, or tape for cold workloads. And that alignment in having the right building blocks of storage on the right media technology is really critical for CSPs to operate and to be at the right level of total cost of ownership for their entire portfolio of storage. So we'll start with the hot tier with SSD flash media at the top. And it's getting so much attention because of the speed and performance, especially for Gen AI workloads and also for data caching resources. SSD definitely has its place, but that performance comes at a cost. And the price of SSD and flash is at a multiple over hard disk drives, and then an extreme multiple over tape for cold storage as well. So even though flash and SSD could cover the entire range of storage operations from a disk perspective inside of the data center, we won't see that as a good decision for financially and economically by operators. And that really leads us to hard disk drive in the warm sector and segment. And we've seen many analysts and industry research firms really show that on average, this might be different depending on the different service platform, but up to about 80% of all data under storage right now in a data center is considered to be warm workload. And HDDs are a high performance technology, really more than sufficient to perform all of the storage operations at a wide range of warm workloads. Tape at the low end of there, and cold data, it's an interesting one because it has by far and away the best TCO. When we look at it for document storage, and tape has a future. We've been long proclaiming the death of tape, and the same thing for HDD now with the emergence of flash and SSD storage. But neither is true. Both technologies will continue on. What we're really seeing is all different media types are increasing in both units and volume and capacities in petabytes year over year. So it really is the case of a rising tide lifting all ships, and all different media types will continue to grow and be utilized. So it really is the mix of these different technologies and aligning it to the workloads that you have as a CSP perspective. The interesting thing with HDD technology, it's a common misperception that because HDDs have been around since almost the time of Intel and introducing the silicon, HDDs it's a experienced and it's a technology that's been in the market for a number of years, but there's a common misperception that it really is a dated or outdated performance and a slow technology, and that's just not the case at all. At Western Digital, we work on rapid innovation, constantly innovating to not only increase the density and the capacity of hard drives, but also on making sure that the drive data is stored reliably on the hard drives on proven existing technologies. And that's important for data center operators. Mechanical side, we've created technologies like HelioSeal and our triple stage actuator, which helps with the exact placement of data on the tracks. And then also some of our storage media technologies as well with ePMR, OptiNAND, and even our Ultra SMR, which helps to extend capacities and really increase that TCO message as well. And we'll see it in the future with HAMR introductions and expanding the capacities. We have line of sight up to and increasing from 100 terabytes within the next 5 calendar years. By 2030 is the target.
Yeah, I think that to me is really where it's exciting, and I think that when you start to look at it, CSPs, and again, I think we all talked to a lot of them over the course of a year, and when you start to talk to them, they really are looking at the fact that they're trying to figure out their TCO models and make sure that they can maximize their customer experience and meet those SLAs at the same time that they are, again, making sure. So, Paul, why don't you, kind of give us a view from a Supermicro perspective of how Supermicro really focuses on the CSP market and how you bring it to them, all of this great technology to people like Iron Mountain and Ironcloud.
Yeah, I think one of the things I really appreciate everyone on this panel is because, again, we're taking a building block approach, and this has been sort of the core idea of Supermicro, starting from a motherboard and then slowly building infrastructure around that to today, where we have these data center building blocks. So we really can deliver everything you need inside of a data center to do whatever kind of application, whether it's cloud service provider or AI, large-scale AI deployment. So yeah, one company can't do it by themselves. They've got to partner because, again, the market changes so fast. If you were to invest in today's technology, well, there's going to be another guy who's going to innovate. And so having this diverse partnerships in the market has given us a real differentiator compared to many of our competitors. And again, with really excited about Ironcloud and what we're going to be able to do there with growing cloud business, et cetera. So from a building block perspective, that's really how we're addressing scale, right? The portfolio that I manage is our storage portfolio, which is only one small part of the Supermicro portfolio. Most people are probably aware that you get overwhelmed with how many parts Supermicro, has, and the selection problem is one of our biggest things. How do we get our customer to the actual server that they're really going to need to deploy the very best solution? So the storage components here really give us abilities to dial in whether it's block storage and as low latency performance as we can get with block storage, or object storage with as much capacity and throughput that you can deliver these cloud services and build upon it and be able to make money selling that. Because again, economy of scale is the other part that we really help our customers deliver solutions for the cloud. And that's pretty much the big picture with Supermicro.
It's great, and I think, again, that kind of leads to some questions I have rattling around in my brain right now that, again, because I think to, take advantage of the fact that Cliff is here, I'm going to go to Cliff first on this and go, given that you've designed your cloud and you've gone through and built out the cloud with Ironcloud at Iron Mountain, what were some of the design considerations that you looked at when you're thinking about building storage as a service?
Sure. Yeah, I mean, great question. And we've heard a lot of really good information that hopefully for those listening have followed along with. When you think about, first and foremost, know your workload. I think almost everyone on the panel has brought up kind of knowing, what in that space from a storage as a service perspective, what workloads are you targeting, right, with the solution that you're trying to build out? Because it matters an awful lot, whether you're thinking about the processors or the hard drives you're going to use, the tiers of storage that you're going to offer to your customers. You need to understand kind of their business and their applications. So by doing so, right, when you get into your design considerations, that'll help you in terms of building out the density, the types. When I look at Ironcloud and think about, we've got a massive amount of that warm tier. We've got high-performing tiers as well. You've got metadata considerations. You need to understand the workload, to understand the sizing of those types of servers as well. And so that all comes into just the physical kind of design considerations. When you, with a company like Iron Mountain and the kind of broad portfolio that we offer, understanding kind of your space, though, becomes real important. We've got a legacy in information management. We've bridged into data management, content management, and so forth. And with the Ironcloud solution, designing again around those specific workloads and those standards. We get into then, the scale considerations for us. We're a global company. We need to think globally in terms of both the security and the standards that we build around. Those become real important. So obviously security at the core of everything that we do. We've heard a little bit about the security offered from Scality, and then of course we've layered some of our requirements on top of that. But that becomes another key design consideration in terms of how you're controlling access, both from a digital footprint point of view as well as physical, sitting within Iron Mountain facilities. That becomes another key aspect. So where are you going to put your cloud, and then how are you going to physically protect that and put your standards in place so that way you can go get and meet both regulatory standards as well as get certifications that I'm sure many of those that are considering becoming a CSP need to consider as well. So all of those things come into the design for sure.
Yeah, and I think that's really interesting because I think, to your point, you need to meet the objectives of the use cases for those customers and make sure that you can do that at scale, make it manageable and repeatable so that you can get density of customers into that space to hit your margin targets and things of that nature. Giorgio, I think when you look at it from the object perspective, what are some of the key features that are required by CSPs from an object perspective?
Yeah, that's a good question. I think of 100 things, I try to get it down to a couple. So if you look at your big object store as a building, it has 10,000 people in it, like 10,000 apartments. That means one of the neighbors has to be bad. So how do you manage a bad neighbor? So there's a bad actor, there's a noisy neighbor, and quality of service is key. So you have to build into the object storage system or the block storage system, quality of service, making sure that one user cannot impact the others. So if somebody has a bug in the code, is doing 10,000 listings per second, you have to block it and make sure the others can still access the service. So that's kind of a built-in to an object store for service providers. You also have power users, and they need to be able to access the system and get the bandwidth that you promised. So you have to optimize and preferential access for some user and make sure the bad actors are not taking advantage. The other feature I would say is delegated administration. So think of a big bank that has a private cloud. They may have 1,000 departments. They want to be able to self-service, and they don't want to have to call IT. So they need to manage their own buckets. They need to manage their own utilization. They need to see what's happening in their own department without having to call anybody. So delegated administration. The third one I would say is precise resource utilization. So it becomes an HPC problem. I can think of one customer, they do 10,000 S3 operations per second. But we have to track each of them because you need to bill. You need to say, this guy consumes 1 million S3 operations. This other department is actually doing that much bandwidth. And you need to track this. And so if you haven't built into the object store initially, it's hard to bolt on after the fact because it becomes a metadata issue and you have to design it from the get-go. So that's another feature that I would say is very required for service providers.
Yeah, I think all of them make a lot of sense. And I think, again, when you start to bring this all together as you scale that and modernize that, I think Rex, from a Block and a Lightbits perspective, where do you see that service providers and how are you helping service providers really focus on the benefits so that they can minimize disruption and really help reduce the cost of modernization as they go in the direction towards software-defined?
Sure. So when you have a foundational component of the service provider's technology, as we do, I think the first thing you have to focus on is lack of disruption. How do you facilitate ease of adoption? We talked about that a little bit earlier in terms of folding in transparently under whatever hypervisor and orchestration the client has. I think there's also a certain bit of humility. How do you establish, for instance, premium tier block storage for low latency as an augment to what you've already built, right? That's really important to do. And so I think, liberating software-defined storage, being able to deploy in a variety of form factors. And usually what our clients find is that they adopt high-performance software-defined block storage to solve a specific problem with a specific workload. Usually, database or analytics workloads, or perhaps Kubernetes at scale, right? And once they do that, it typically expands organically to kind of bleed into the utility tier. But I think understanding that point of entry and defining where that fits and how you can help the cloud builder, the service provider, establish that premium tier pretty seamlessly is what we try and accomplish.
Yeah, I think so, and I think we'll go to Mark here, and I think you have a slide for us as well that we'll pull back in here. That really, when you start to look at this, and you kind of brought it up from a perspective of where things kind of pull together, I think you mentioned it, kind of Kubernetes. Not everything is AI. I know everything in the news is AI, but there's still these other workloads, and you still have to run things like, cloud native applications and Kubernetes. Mark, you were talking about how really your open source, the Kubernetes IO resource isolation plugin, to help people battle that noisy neighbor. Why don't you kind of talk to some of the real world statistics that you're seeing about that?
Yeah, sure. I mean, this problem comes up in a wide range of cases. Like, for instance, Spark Shuttle is a good example. You can have 100 containers running on a server, one of them goes into a shuttle, and boom, everybody's on their knees because all the resources are going into one guy. And so how do you democratize the access to the physical storage devices? Well, you can use Linux cgroups to enforce that kind of limitation, but you need the infrastructure that actually allows you to put that to work for you. So in this example I'm sharing here, we're looking at database performance, just a MySQL type of environment. And then what we did is, we looked at sort of a baseline of performance and then turned on FIO to create some kind of extreme noise on one of the containers in a deployment. And you can see all the red in the third column there. Every measure of performance, whether it's latency or throughput, just goes to hell in a handbasket. And so, how do you prevent, that kind of stuff from happening in real deployments so that, everybody's kind of working together happily? So by, putting a limit on how much resources everybody gets, a reasonable limit, you get to the last column there in that chart, and what you can see is a lot of blue. So particularly for the tail latency, you just preserve the latency responses that everybody's getting. And that's very important. And even the throughput, while it is slightly diminished, it's not significantly diminished. So overall, you get a huge win, particularly in customer experience. And we've done this not only for SQL databases, but we've done it for Kafka. You can do it for Spark. I mean, there's so many different workloads where this problem comes up. So we know for sure this works in real world. What we'd love to do is get more community participation in this. And this can be put into public cloud. I mean, it can work. This is pretty widely available in terms of platforms where you can put this to work.
Awesome. I think to me that makes a lot of sense for as organizations and CSPs are looking to build out that infrastructure. Again, they have to have all these different options because they have to hit different cost vectors for different clients and different workloads. Mark, we're going to go to you on, hard drives are dead, long live hard drives, right? I've heard this about so many technologies. The hard drives aren't going anywhere. I mean, it isn't. But help us understand where they really fit from a CSP perspective, because they do have a use, big time.
Yeah, thanks, Rob. We talked a little bit about the workloads, hot, warm, and cold, and the warm workload can be getting up to about 80% of all data stored, and that's going to continue. The mix should stay relatively the same. Different again by the different CSP offerings. But again, hard drive has far and away the leading TCO for that segment for the warm data storage structures. And that will continue, especially as hard drives continue to expand in capacity. Right now with UltraStar, we introduced the first 11-disk, 26 terabyte CMR technology hard drive. That's an amazing amount of surface storage area from a media perspective to have inside an existing 3.5-inch hard drive that's compatible in Supermicro platforms. And so any expansions continue to increase in capacity, but not increase in storage power draw relative to the capacity increases. So we're delivering higher capacities at similar energy draw and power consumption standpoints. And that beyond our CMR technologies, we also have our shingled magnetic recording technologies, which are at 30 terabytes today and can expand up to, we'll see higher amounts in this next calendar year coming up. And then those technologies will go into HAMR umbrellas, and so it'll just help us to expand the capacity points and continue to drive that TCO advantage for the foreseeable future.
Yeah, and I think that's so important in the CSP market when you look at margins and you look at how they make money and how they have to have varied workloads. I definitely think it's key. So Paul, again, you guys are bringing it all together at a system level perspective. What is Supermicro bringing to the CSP party?
So really, it's building on open standards. And I think that's demonstrated here, that we make it easy for partners to build solutions, and there's not a mystery because we are looking at the same standards and building our products so that they can be integrated into, commercial solutions and even open source. That's probably core to these building blocks. The other thing that we focus on is power efficiency. So that's been brought up a few times here, and for people to be able to meet their performance goals within a power budget is really significant, and that's really the next generation is really focal point. And so things like, direct liquid cooling and other techniques that we're using to build that efficiency without leaving any of the performance on the table.
Yeah, I think that all makes sense, and I want to thank you guys all because I think right now that was just so much knowledge heaped upon the CSPs, and thank you for coming as a customer to kind of break, where the rubber meets the road. Really appreciated that. So thank you all for coming on board today.
Thank you.
Thank
Thank you.
Thanks.
And thank you for watching this episode of the Supermicro Open Storage Summit. Stay tuned, we'll be back with more.